To effectively compare the cost of different lighting options, several software programs can assist you. Firstly, EnergyCAP is a comprehensive energy management software that includes lighting calculations. Secondly, lighting design software is specifically designed for lighting professionals, allowing for cost comparisons between different fixture types. Thirdly, the Energy Star Portfolio Manager is a free online tool from the Environmental Protection Agency that lets you track and compare energy usage and costs. Fourthly, there is a Tate savings calculator specifically designed to compare the cost of Tate fluorescent fixtures to other lighting types. Several variables must be considered for an accurate cost comparison. These include the number of fixtures, the wattage of each fixture, the operating hours per day, and the electricity rate expressed in dollars per kilowatt hour. Here are the steps to calculate the costs. Firstly, determine the total wattage used by the fixtures. For example, if you have 108 fixtures each using 250 watts, the total wattage is 108 multiplied by 250, which equals 27,000 watts or 27 kilowatts. Secondly, calculate the daily energy consumption in kilowatt hours by multiplying the total wattage in kilowatts by the operating hours. If the lights operate for 12 hours a day, then the daily energy consumption is 27 kilowatts multiplied by 12 hours, equaling 324 kilowatt hours. Thirdly, multiply the daily energy consumption by the electricity rate to get the daily cost. If the electricity rate is 15 cents per kilowatt hour, or $0.15 per kilowatt hour, the daily cost is 324 kilowatt hours multiplied by $0.15 per kilowatt hour, which equals $48.60. Fourthly, annualize the daily cost by multiplying by the number of days in a year. Assuming 365 days in a year, the annual cost is $48.60 multiplied by 365 days, which equals $17,739. Fifthly, compare the cost of the high-intensity discharge fixtures to the alternatives such as light-emitting diode or Tate fluorescent lighting, using the software programs mentioned above. In addition to energy costs, there are other considerations. These include maintenance costs such as bulb replacements, the heat output of the fixtures, and aesthetics and light quality. It's important to carefully consider all of these factors when making a decision. While high-intensity discharge fixtures may have a lower initial cost, they typically have higher operating and maintenance costs compared to light-emitting diode or Tate fluorescent lighting. To elaborate on the calculation process, let's consider a more detailed example. Suppose you are comparing 250-watt metal halide lamps with 32-watt Tate fluorescent lamps. You plan to install 108 fixtures in each scenario and operate them for 12 hours per day. The electricity rate is $0.15 per kilowatt hour. Firstly, let's calculate the annual energy cost for the 250-watt metal halide lamps. The total wattage is 108 fixtures multiplied by 250 watts, which equals 27,000 watts or 27 kilowatts. The daily energy consumption is 27 kilowatts multiplied by 12 hours, which equals 324 kilowatt hours. The daily cost is 324 kilowatt hours multiplied by $0.15 per kilowatt hour, which equals $48.60. The annual cost is $48.60 multiplied by 365 days, which equals $17,739. Secondly, let's calculate the annual energy cost for the 32-watt Tate fluorescent lamps. The total wattage is 108 fixtures multiplied by 32 watts, which equals 3,456 watts or 3.456 kilowatts. The daily energy consumption is 3.456 kilowatts multiplied by 12 hours, which equals 41.472 kilowatt hours. The daily cost is 41.472 kilowatt hours multiplied by $0.15 per kilowatt hour, which equals $6.22 approximately. The annual cost is $6.22 multiplied by 365 days, which equals $2270.30 approximately. Comparing the two options, the 250-watt metal halide lamps would cost $17,000, $739 annually, while the 32-watt Tate fluorescent lamps would cost approximately $2270.30 annually. This represents a significant energy savings by using Tate fluorescent lamps. Now, let's consider the maintenance costs. Metal halide lamps typically have a shorter lifespan than Tate fluorescent lamps or light-emitting diode fixtures. If metal halide lamps need to be replaced every 2 years at a cost of $20 per lamp, the annual maintenance cost would be 108 lamps multiplied by $20 divided by 2 years, which equals $1080 per year. Tate fluorescent lamps may need to be replaced every 3 years at a cost of $5 per lamp. The annual maintenance cost would be 108 lamps multiplied by $5 divided by 3 years, which equals $180 per year. Light-emitting diode fixtures may have a lifespan of 5 years or more, significantly reducing maintenance costs. In this example, even with potential maintenance costs, the Tate fluorescent lamps offer a substantial cost savings compared to the metal halide lamps. To delve even deeper, let's explore the concept of payback period when switching from high-intensity discharge to light-emitting diode lighting. The payback period is the amount of time it takes for the energy savings to offset the initial cost of the new lighting system. Suppose the initial cost of installing 108 250-watt metal halide fixtures is $50 per fixture, totaling $5,400. The annual energy cost, as calculated earlier, is $17,739. Now, consider replacing these with 108 light-emitting diode fixtures, each consuming 90 watts. The cost per light-emitting diode fixture is $100, totaling $10,800. The total wattage for the light-emitting diode fixtures is 108 multiplied by 90 watts, equaling 9,720 watts, or 9.72 kilowatts. The daily energy consumption is 9.72 kilowatts multiplied by 12 hours, equaling 116.64 kilowatt hours. With an electricity rate of $0.15 per kilowatt hour, the daily cost is 116.64 multiplied by 0.15, which is $17.496. The annual cost is $17.496 multiplied by 365 days, totaling $6,386.4. The annual savings from switching to light-emitting diode is the difference between the high-intensity discharge cost and the light-emitting diode cost, or $17,739 minus $6,386.4, which equals $11,352.96. The incremental cost of switching to light-emitting diode is the light-emitting diode fixture cost minus the high-intensity discharge fixture cost, or $10,800 minus $5,400, which equals $5,400. The simple payback period is calculated by dividing the incremental cost by the annual savings, or $5,400 divided by $11,352.96, which equals approximately 0.476 years, or about 5.7 months. This means that the investment in light-emitting diode lighting would pay for itself in less than 6 months due to energy savings. In addition, light-emitting diode lighting typically has very low maintenance costs due to its long lifespan, which would further improve the return on investment. Furthermore, one should consider the potential for rebates and incentives from utility companies or government programs. Many utilities offer rebates for upgrading to energy-efficient lighting systems, which can significantly reduce the initial cost and shorten the payback period. These rebates can vary depending on the location, the specific products installed, and the utilities programs. Checking with local utility companies or energy efficiency organizations can reveal available incentives. Another factor to consider is the impact on heating and cooling loads. High-intensity discharge lighting produces a significant amount of heat. This heat can increase the cooling load in the summer, leading to high air conditioning costs. Switching to more energy-efficient lighting, such as light-emitting diode or Tate fluorescent, can reduce the heat output and lower cooling costs. However, In colder climates, the heat from lighting can contribute to heating the space, potentially offsetting some of the heating costs. A thorough analysis should consider these interactions between lighting, heating, and cooling systems. Light distribution and control are also important considerations. Different lighting technologies offer different light distribution patterns. Metal halide lamps often produce a more concentrated light, while tate fluorescent and light-emitting diode fixtures can provide a more diffused and even light distribution. Depending on the application, one type of light distribution may be more desirable than another. Also, dimming capabilities and lighting controls can further enhance energy savings and improve the lighting environment. Light-emitting diode fixtures are particularly well suited for dimming and can be integrated with occupancy sensors and daylight harvesting systems to reduce energy consumption when light is not needed. Considering the long-term effects, it's wise to remember that technology is always evolving and improving. Light-emitting diode technology is advancing rapidly, with increasing efficiency and decreasing costs. As light-emitting diode technology continues to develop, the energy savings and cost-effectiveness of light-emitting diode lighting are expected to improve even further. Staying informed about the latest advancements in lighting technology can help in making the best long-term decisions. In summary, to accurately compare lighting costs, consider the initial costs, energy consumption, maintenance, heat output, light distribution, control options, and potential rebates. Use available software programs and calculators to analyze the data and make informed decisions based on your specific needs and circumstances. By carefully evaluating all of these factors, you can choose the lighting system that offers the best balance of cost effectiveness, energy efficiency, and lighting quality.